The search for a second Earth has long enthralled readers of science fiction. What rich and varied life could it contain? What would such a discovery mean for humanity's own place in the universe? How many similar planets are out there? The question is more than a philosophical puzzle, and it comes with a hard scientific edge that should be considered sooner rather than later. As the search for planets beyond the solar system widens and public interest in the quest grows, at which point should astronomers declare the hunt for another Earth a success? In this video, we're going to take a look at what has already been discovered and what may happen should we successfully discover Earth 2.0. Over the past decade, our understanding of what planets exist around our stars other than our own has exploded. The number of known exoplanets has risen from only a few dozen just 11 years ago to more than 4,000 confirmed exoplanets, pioneered by the spectacular success of NASA's Kepler mission. They came in a wide variety of sizes, orbital distances, and around all types of stars. It's brought a number of existential questions into the realm of science among professionals and amateurs alike. When will we find our first inhabited planet beyond the solar system? Are any potentially habitable by humans? And which planets in which solar systems are the most Earth-like? When we look around the solar system at the planets, moons, and other worlds that surround us, it's pretty clear that Earth is something special for a number of reasons. Earth is the only world we know of where life arose, sustained, thrived, transformed the biosphere, and became complex, intelligent, and technologically advanced. When scientists say they are looking for Earth 2.0 or an Earth-like exoplanet, they are looking for conditions that are similar to the ones that we are fortunate enough to experience. Even if a planet is deemed to be habitable, it doesn't mean that it resembles Earth very much. A habitable planet is a rocky planet located in the habitable zone, allowing water to stay on the planet's surface in its liquid form. Venus and Mars are habitable planets, but they are definitely not like Earth. There are three major qualities that we would look for when searching for an even better version of Earth. The first being the need for sunshine. Our sun's lifespan is about 10 billion years. K-type dwarf stars have lifespans of about 70 billion years. So if we found an exoplanet orbiting a K-type star, there would be more time for life to evolve and live on it. The next major quality is temperature. A planet that is too hot or too cold would not be able to host the life forms we would need to survive, such as vegetation and animals. But if we find a planet that is 5 degrees centigrade warmer than Earth and has more water, we could be looking at an Earth 2.0 covered in lush, biodiverse rainforest. The third thing of importance is size. Gravity retains a planet's atmosphere, and there is a direct relationship between gravity and a planet's size. If we find a planet that is only 1.5 times larger than Earth, it would be able to hold on to its interior heat and maintain its atmosphere for a longer time. But it's not always best to go bigger. While Earth-sized exoplanets are usually rocky, about 50% of the exoplanets larger than Earth are gas giants. And if an exoplanet is too small, it would likely be less productive and fruitful, like Mars. In 2020, astronomers discovered a planet nearly the same size as Earth that orbits in its star's habitable zone, where liquid water could exist on its surface. The presence of liquid water also indicates the planet could support life. This newly found world, Kepler 1649c, is 300 light-years away from Earth in the constellation of Cygnus and orbits a star that is about 1/4 the size of our Sun. There would not be any seasons on Kepler 1649c. A full orbit only takes 19.5 Earth days, so we would need to get used to that. And it would be tidally locked, which means one side of the planet constantly faces its Sun, while the other side faces space. What's exciting is that out of all the 4,000 plus exoplanets that have been discovered using observations from the Kepler Space Telescope, this world is most similar to Earth both in size and estimated temperature, NASA said. Although NASA said that there are other exoplanets estimated to be closer to Earth in size and others may be closer to Earth in temperature, there is no other exoplanet that's closer to Earth in both of these values that also lies in the habitable zone of its system. This newly revealed world is only 1.06 times larger than our own planet. Also, the amount of starlight it receives from its host star is 75% of the amount of light Earth receives from our Sun, meaning the exoplanet's temperature may be similar to our planet's as well. But unlike Earth, it orbits a red dwarf star. Though none have been observed in this system, this type of star is known for stellar flare-ups that may make a planet's environment challenging for any potential life. Scientists discovered this planet when looking through old observations from the Kepler Space Telescope, which the agency retired in 2018. Although NASA's Kepler mission ended in 2018 when it ran out of fuel, scientists are still making discoveries as they continue to examine the information that Kepler sent back to Earth. The more data that is collected, the more signs seem to be pointing to the notion that potentially habitable and Earth-sized exoplanets are common around these kind of stars. With red dwarf stars almost everywhere around our galaxy, these small, potentially habitable and rocky planets around them, the chance one of them isn't too different from our Earth looks a bit brighter. Now, for the bad news. We have yet to find another Earth with life, intelligent or not. Observing signs of possible microbial life in exoplanet atmospheres is currently out of reach. No convincing evidence of advanced technology, artificial signals by radio or other means, or the telltale sign of, say, massive extraterrestrial engineering projects has yet crossed our formidable arrays of telescopes in space or on the ground. And finding non-intelligent life is far more likely. Earth existed for most of its history, 4.25 billion years, without a whisper of technological life, and human civilization is a very late-breaking development. Is there life beyond Earth? So far, the silence is deafening. While the chances of finding life elsewhere remain unknown, the odds can be said to be improving. A well-known list of data needed to determine the likely abundance of life-bearing worlds, though highly conjectural, is known as the Drake equation. The equation was written in 1961 by Frank Drake, not for purposes of quantifying the number of civilizations, but as a way to stimulate scientific dialogue at the first scientific meeting on the search for extraterrestrial intelligence. So what if we decided that Kepler 1649c is worthy of becoming Earth 2.0? What would happen next? Using our current technology, it would take at least 2,000 years to reach this Earth 2.0. And since this planet is so far away, we only know about its size, the distance to its star, and the makeup of its atmosphere. So we could pack up all our worldly goods, family and friends, and take an extremely long trek to Earth 2.0, only to discover it's more like a Neptune 2.0, which is not a planet we could survive on. We would need much more information before we send humans to any possible Earth 2.0s. Right now, NASA is developing a tiny probe to travel at 1/5 the speed of light, which would greatly expand our knowledge of exoplanets. There are also other options for Earth 2.0. A moon receives direct solar energy from its star, and the planet it orbits reflects solar energy toward it. So maybe a moon could be more suitable for human life than an exoplanet. The most Earth-like moon in our solar system is Titan, Saturn's largest moon. So if we want to save thousands of years traveling, maybe Titan could make a good second home for us. We once thought that life required sunlight, but the discovery of life around hydrothermal vents many miles beneath the ocean's surface taught us that even in the absolute absence of sunlight, life can find a way. We thought that complex life could never survive in the harsh environment of space, but the tardigrade proved us wrong, entering a state of suspended animation in the vacuum of space and successfully rehydrating when returned to Earth. It has to make you wonder about what else might be out there. Could there be life in the subsurface oceans of Jupiter's moon Europa, Saturn's moon Enceladus, Neptune's moon Triton, or even cold, distant Pluto? All of them orbit large, massive worlds which exert tidal forces on the planet's interior, providing a source of heat and energy, even in an environment where no sunlight can penetrate. So who knows, one day we may well discover Earth 2.0, but in the meantime, the scientists have got plenty of time to find it. How would you feel about a trip to Earth 2.0 if it were possible? Please like this video if you've enjoyed it. If you want to see more videos like this one, then subscribe to Brain Impact for more. Thanks for watching.